Hi, welcome back to Sagacity Science Hub. Today we'll be looking at LUSSAC'S law of combining volume. If you've not watched the first video on LUSSAC'S law of combining volume, do well to watch and also don't forget to subscribe to my YouTube channel. Let's solve another jump question under LUSSAC'S law of combining volume. 10 cm cube of carbon monoxide, which is CO, is mixed and sparked with 100 cm cube of air containing 21% oxygen. If all the volume are measured at standard temperature and pressure, the volume of resulting gases would be, these are the options. Let's solve. The first step is to write out the equation for the reaction. What are the reactants? We have CO and then we have air. Note that air is a mixture of gases and oxygen is the only reactive component in air that reacts with CO. So what are my reactants? Like I said, first step is to write out the equation. My reactant is CO, oxygen, which is a gas, and when CO reacts with oxygen, you have carbon 4 oxide. This is a gas, and make sure your equation is balanced. After writing out the equation for the reaction, make sure it is balanced. I have 2 here, and then I have 2 here. After writing out the equation for the reaction, write out the mole ratio. Mole ratio, I have 2 here, I have 1, I have 2. Note that in gas equation or in any gas equation, the mole ratio can be represented as volume ratio. Don't forget, LUSSAC'S law states that when gases react, they do so in volume. So represent the mole ratio as volume what? Ratio. After writing out the mole volume ratio, what's the next step? Write out the given volume. And how do you get the given volume? Travel down to the question. What's the given volume of CO? 10 cm cube. What's the given volume of oxygen? The volume of air is 100 cm cube containing 21% oxygen. So how do I get volume of oxygen? 21%, that's 21 over 100 times the volume of air, which is 100. So what's the volume of oxygen? 21 cm cube. What's volume of the products? Unknown. After writing down the given volume, the next step is to write out the reacting volume. And how do you get the reacting volume? Notes. That you have 10 cm cube of CO does not necessarily mean that all of it will react. Or that you have 21 cm cube of oxygen does not mean that all of it will react. It is your duty to get the reacting volume. And how do you get the reacting volume? Let's call the first step case 1. Write out the volume ratio from the equation. I have 2 and 1. Write down the given volume of one of the reactants and then make the other a variable. Represent it with a variable. So I'm writing down the given volume of CO and then representing oxygen with X. When I cross multiply, I'll be left with 2x is equal to 10. And when I make 10 subject of formula, I'll have 10 divided by 2. Sorry, when I make x rather subject of formula, I'll have 10 divided by 2 to give me 5 cm cube. What's case 2? Repeat the same step. Write down the given volume of the other variable and then represent the other with. Write down the given volume of the other reactant rather and then represent the other with a variable. Also write down your volume ratio, which is 2 and 1. What's the given volume of oxygen? 21. Right? And then I represent CO with a variable, which is X. When I make S subject of formula, what will I have? 2 times 21 to give me what? 42 cm cube. Now compare what you solved with what you have in the equation. I have 21 cm cube here, oxygen, and I have a value lesser than 21 cm cube. So it is possible that the reacting volume is 5 cm cube. Now check out for CO. I have 10 cm cube and then I'm having 42 cm cube. It is practically impossible to have a reacting volume higher than the given volume. So it's not possible, okay? So what is the rule? When you get a lesser value compared to the given volume, make use of it. So for oxygen, this is lesser than 21, so we are making use of this. We are not making use of this. And I'm sure you know why. So under CO, I can't make use of 42 cm cube. I write down 10 cm cube. This simply means all of it will react. And then under oxygen, what will I write down? 5 cm cube. How do I get the volume of the product? Very simple. Which of the reactants did we solve for? We solved for oxygen. We are not using the value we got for CO. So we are making use of the value we got for what? Oxygen. So compare the volume ratio of oxygen, that is 1 will give us 2, and then what will 5 cm give us? We call it X. We'll make X subject of formula, cross multiply 5 times 2 to give me 10 cm cube. That is the volume of the product is what? 10 cm cube. Very simple. So can we subtract? It simply means 10 cm cube of CO reacted. Now 21 minus 5, what are we going to have? 16 cm cube. That is the unreacted gas. 16 cm cube. Okay, 16 cm cube. And what's the volume of the product? 10 cm cube. Now let's travel down to the question. We are being asked the volume of resulting gases. Now the volume of resulting gases is equal to the total volume of all the gases present after the reaction has finished. Okay, so what are the gases present? Resulting gases, volume of resulting gases. Like I said, that the volume of resulting gases is equal to the total volume of all gases present after the reaction has finished. What are the gases present? We have unreacted volume of oxygen, which is 16 cm. We have the volume of the product, which is 10 cm cube. And we also have the volume of the other components of air that did not react. Okay? Volume of unreacted gas, unreacted oxygen, plus volume of the product plus volume of the unreacted components in air. Unreacted air components. The other components of air did not react. It was only oxygen that reacted. And after the reaction, we have 16 cm cube of oxygen that did not react. So we have 16 cm cube plus what's the volume of the product? 10 cm cube. Remember, the volume of air is 100 cm cube. And just 21 of this 100 cm reacted. So what's the volume of unreacted? That will be 79 cm cube, right? Good. Unreacted components of air, we have 79 cm cube. So when I add this, what will I have? 105 cm cube. Now let's travel down to the option C. So this is very simple. LUSSAC'S law of combining volume is a very interesting topic in chemistry. Understand the rule, understand the steps, you are good to go. Alright, bye and see you in my next class.